My name's Ken Goldberg, and I have the pleasure to be hosting the panel right now. This is going to be right now on the future of work. And I want to just take a very brief moment to thank the real organizers behind today's event. Camille Crittenden and Brandy. Where's Brandy? Brandy, thank you very much. Brandy Neineke. Really, they've done a countless amount of work with the wonderful Citrus staff over the past few months in putting this all together. So what we're going to talk about over the next hour is the issue of inclusiveness in the context of AI and the many concerns about work and the future of jobs. I want to dedicate this session to a particular colleague and friend who we lost just over a week ago. His wife is here. And Hubert Dreyfus was a long-standing mentor. He was a great critic of artificial intelligence over the years and wonderful philosopher, a beloved teacher here at Cal. And I think he would be delighted to be here today. So it's in his memory that we're going to do this session. What I want to talk about is... and we have been hearing a lot about AI. In the past few years, it's been a huge resurgence in movies and books, and there have been results. We have had a number of major breakthroughs in the field, like the AlphaGo results in the games, and we also have seen a huge resurgence in press coverage and things like this, where the rise of the robots, discussions basically predicting that this is going to have cataclysmic effect on jobs. And there have been a number of changes in jobs. There's no doubt about that. No one can deny that there has been loss of jobs, especially in the middle range of jobs, and a lot of income inequality and suffering, not only in the United States, but around the world. A lot of people are concerned. Essentially, it comes down to, is this going to get worse? Is this going to be catastrophic? And and many of us may be wondering, am I going to lose my job too? Are robots coming? Are they about to steal our jobs? And this is causing what I believe is a great deal of automation anxiety. And this is really is for many people, especially workers who may not be as aware of all the details. They're reading this and having a sense that this is going to be very, very disruptive to them. Now, I want to point out, as a researcher in this field, that this is a very old story. In fact, the fears of technology, of robots, of our human creations taking over are very deeply rooted in Western culture. And in fact, also the fears of someone taking our job is also very deeply rooted. So 100 years ago, it was the yellow peril. It was the Chinese who were going to take our job. There's a long tradition of looking for scapegoats for economic disruptions. I love this quote that Oliver Morton from The Economist said a year ago, is that robots are the new scapegoats. Robots are immigrants, but this time from the future. And they are very convenient scapegoats, and indeed. And I want to talk about that. I do feel that there's a lot of advances. My own area is cloud robotics, and we have a lot of work going on here at Berkeley in this area. There's also major advances in networking and connectivity that's leading to this Industry 4.0, this fourth wave. I think that is very important. But I also think it's important to temper this with reality, that the claims are overstated in many, many cases. I'm very skeptical, and I'm going to offer right now $20 $100 bets are the following. That I want to argue the proposition is that driverless cars will be rare, meaning under 5% of the cars, in Pittsburgh, Pennsylvania in January 2027. So that's 10 years from now. You can sign up at that driverless cars dash bet, and we'll see what happens. But I'm going on record as saying driverless cars are not around the corner, despite what Uber and others are saying. It's a very hard problem. They've been saying fully autonomous cars driving around, picking your kids up and taking them to soccer practice. I don't think that's going to happen at least in 10 years. I'm not even sure it's going to happen in my lifetime. All right, but there's going to be many other jobs that are safe. These kind of jobs, when you're doing really assembly and construction jobs, they're safe. We do not have robots about to do those. These kind of jobs in the kitchen, robots are not even close to being able to take over these jobs. Jobs and many times of caring for people in many different environments, robots are not able to do that. There's a lot of talk about this idea of a singularity, that this is impending, this idea that we're going to suddenly, robots are accelerate and take over. And I want to push back on this, and I have a concept I want to propose called multiplicity. That instead of singularity, multiplicity is a much more constructive vision of the future. And what it's based on is the idea of combinations of people and machines. And we know that if we take combinations of machines, there's a well-known theory about this, random forests, actually developed here at Berkeley, that shows mathematically that if you take a diverse group of machines, you actually get better performance than a single machine. And the analogous thing is true for groups of people. When you have a diverse group of people working together, you often get very, very superior results than a homogeneous group. And we might characterize this as not just AI, but intelligence amplification. In other words, trying to think of the humans, how do we incorporate these advances into making humans better? There's been historical examples of this. The high school movement was when automation started to move into the farms. We responded, America responded by basically increasing education, changing the way we thought about education, making high school mandatory, and it was very successful. So this is what I believe is the future, that we're going to go from an old school model of education, of uniformity, consistency, obedience, rigidity, and predictable schooling, to this new wave, where we're going to be emphasizing diversity, variety, resistance, innovative approaches, and surprising outcomes. That, I think, is I'm extremely hopeful. So although I think that advances are coming for artificial intelligence, they're not coming as fast as are being predicted, and I think there's reason for hope, for optimism. Over to my colleague, Brad DeLong. He is a professor of economics here at UC Berkeley. He is a Deputy Assistant Secretary of Economic Policy at the US Treasury. And he serves as Research Associate for the National Bureau of Economic Research, and he's the first chief economist of the Blum Center for Developing Economies. Brad.
Okay, thank you very much. Let me follow the example of our Lord and Master AlphaGo and take the high ground, the hyper-Olympian and very long-run historical point of view. The human brain is a massively parallel supercomputer that fits inside half a shoebox and draws 50 watts of power. It is an amazing innovation, analysis, and creation machine. 600 million years of proto-mammalian and mammalian evolution coupled with a genetic algorithm mean that almost every single human can solve AI problems that are far beyond our current reach. So much so that what our machines find impossible, our brains find so trivially easy that we call such capabilities, quote, unskilled, unquote. That's our brains. Human fingers are amazingly fine manipulation devices. Human back and leg muscles, especially when testosterone soaked, are quite good at moving heavy objects. And so back in the environment of evolutionary adaptation, we used our brains, our big muscles, and our fingers to lead interesting, if stressful, and short lives. But history has rolled forward. As history has rolled forward over the past 50 or 70,000 years or so, we have done other things to add economic and sociological value than use our backs, our fingers, and our brains. Over the long historical sweep, backs and fingers have declined, and we have turned many of us into, instead, robots ourselves, performing simple, routinized, repetitive tasks as microcontrollers for domesticated animals and machines, as relatively simple accounting and software bots keeping track of stuff and information, as personal servitors, and as social engineers trying to keep all those people and all those things controlled by brains, especially perhaps trying to keep all those controlled by the most testosterone-soaked ones, working together harmoniously, but with limited success, while remaining innovators, analyzers, and creators as well. Now, backs started to go out with the domestication of the horse. Fingers with the invention of the spinning jenny. But microcontrollers, accounting bot paper shufflers, and humans as robots we cannot yet build took up all the job slack. Every horse needs a microcontroller, and a human brain is the only possible one, even today, to a large amount. Every textile machine needs a human watching it at least part of the time because it doesn't know when it's gone wrong, et cetera, et cetera. But now we can finally peer into a future in which the microcontrollers and the accounting bots are on their way out too. And so, fortunately, are the jobs that treat humans as simple robots. Being a cog in the machine that is Henry Ford's River Rouge assembly line is an occupation that vastly, vastly underuses the human brain and its capabilities. It's not really a human job at all. So that leaves us with a future of work made up of us as personal servitors, as social engineers, as innovators, analyzers, and creators. And here we have some problems, right? That is, the market economy will amply fund AI that replaces workers in capital-intensive production processes by machines. Such are large scale, such are oligopolies. Oligopolistic firms profit from such R&D because they capture a large share themselves of the improvements in efficiency in their complicated value chains. And there is no equivalent market force funding AI that assists and amplifies workers in labor-intensive production processes. The first, shedding workers in capital-intensive production processes because of AI, is absolute poison for equity and for equitable growth. The second, amplifying the capabilities of workers in labor-intensive production processes, is gold. Utopia or dystopia, heaven or hell, over to you. And in that you, I primarily include Shankar Sastry, because firms will not invest on a large scale in AI that amplifies the capabilities of labor in labor-intensive industries. They will focus on the capital-intensive oligopolies. But NGOs, like an engineering school at a public university, they can act differently. So over to you. And let me stop there.
Thank you, Kostas. Good. All right, we have a new word. I also want to reiterate. I think this is exactly the mission of this university. In fact, Berkeley, I think, is outstanding in this direction of bringing together multiple disciplines, which is another sense of inclusivity that we haven't talked about so much today. Well, our next speaker is James Manica. He is a director. He's the director of the McKinsey Global Institute, where he does research on the global economy, including growth, productivity, competitiveness, digital economy, automation, and the future of work. I also am proud to say that we have something in common, and that we were both born on the continent of Africa. James.
Thank you. Thank you, Ken. I'm delighted to be here. We're just going to pull up some slides. Ken encouraged me to talk about some of the work we've been doing looking at the question of the impacts of AI automation on jobs and productivity. And I'm going to draw from some of the work we've been doing. But a couple things first. As an engineer, so I did my PhD 20 years ago in AI and robotics before it became interesting. No, but seriously, I think one thing that's been quite striking is that in the last 5 or 6 or 8 years, we've made amazing progress on the technology, whether it's robotics, AI, machine learning, deep learning. The progress has just been amazing breakthrough. I think it's also the case, now that I spend my time thinking about the economy and business, that it is the case, and a case can be made, that this is actually good for businesses. They'll become more efficient, more productive, and it's also good for the economy. Because we know that if you look at the long history of economic growth, it actually matters that we have productivity. Productivity matters for economic growth, and we know that these technologies will contribute to economic growth. So I'm not going to make the first or the second case in this discussion. I want to focus my remarks on the last point, which is, what about jobs? Knowing that we know that there's some good things that will come out of the first 2 points on the page. So what about jobs? Well, first of all, right now, there's a lot of studies out there that are looking at the question of impact on jobs. And I think one way to think about these studies that are out there, and this is just a sampling of them, they roughly fall into 2 categories. I think there's one group of studies, and the Frey and Osborne work is a good example of that, where people have taken an occupational view. They've looked at jobs and looked at the question of to what extent can this job be automated or not. We're probably at the other end of the spectrum here, maybe somewhat similar to the work that the OECD has been doing, where we've taken a different approach. We've tried to understand what happens at the task and activity level. And the reason for thinking about it that way is we know that most activities and occupations or jobs that any of us do consist of multiple activities. And some of those are, any one of our occupations, there are 20, 30 different tasks that we do that make up that occupation. Some of those are more automatable than others. So that's the approach that we've taken. And I want to make a couple points about some of the insights that have come from that work. And I may come back to this chart. Let me describe 3 things that we've done. First was we've taken a look at something like 2,000 activities that happen in the economy. Think of an activity as something like data gathering, analysis, and at the level of kind of 2,000 activities. We know how that relates to the roughly 800 or so occupations in the BLS data set that classifies occupations. We've also done a third thing, which is to look at what are the capabilities required to do those tasks. We know that some of those capabilities are mechanical, so you have to be kind of manual dexterity to be able to move and manipulate things. There's a whole bunch of things that are physical capabilities of that form. We also have motor skills and so forth. We know that there's some capabilities that are more cognitive, the ability to calculate things, the ability to recognize and make inferences and so forth. We also know that there's some abilities that have to do with kind of being able to sense things and intuit things. So there's something like the 18 capabilities that we've looked at. Then we've also looked at what can technology do today, currently demonstrated capabilities across all of those, to understand, are we closer to matching human capability with what we can demonstrate today? So we're not looking at things that are 40 years out, but things that are demonstrable today to get a sense of what's easy to automate or not. So if you take that approach, what we found is that, and this is a grouping of the kinds of activities that we've looked at, and we haven't got to jobs yet, this is just activities. We find that, and we group them into roughly these 8 categories. There's a whole bunch of activities that you might call managing expertise, interface, and working in very unpredictable physical environments. Those are actually very difficult to automate, technically. As a technical question, can machines do that or not? Those are actually relatively difficult. Whereas there's a bunch of things at the far right of this chart that actually technically, as a technical question, are easier to automate. So things that involve collecting data in one form or another, things that involve processing data, things that involve doing physical work but in highly predictable environments. So think of an assembly line, for example. That's a very highly predictable environment. You can arrange things to be where you want them to be, the lighting to be what you want it to be, and so forth. So what you see in this chart is that whenever those activities on the right are prevalent in occupations, those are relatively easy to automate. And when you look at that in the context of the US economy, those activities in the economy, again, not jobs, activities, they make up something like 51% of activities we pay wages for. So that's a big number. This is activities. So then you can ask the question, how do those activities map to sectors? What's the density, if you like, of those activities? As you can see, I guess some of this is included by the chairs. There's some sectors up at the top where the density of the oranges and the reds and so forth are more dense than others. By the way, the report that has all this stuff is available. Happy to circulate it. But you'll see that there's some sectors where the activities have a high density. So places like mining, retail, transportation. So the people worry about the truck drivers. I think that's a reasonable worry. Truck drivers, manufacturing, and so forth. Whereas there's some sectors down at the bottom where the density is not quite as high of the easily automated activities. You can ask the question, so does that mean all jobs then get automated, which is one of the questions that's out there. Well, if you look at the activity level, you get a slightly different view. So if you say, so which occupations have almost all of the activities that they do in that occupation that are automatable? The conclusion is actually not a very large number. So we conclude that it is based on current technologies today, that number from our analysis looks more like 5%. The OECD, when they've done a slightly methodologically similar analysis with slightly different data sets, they get to a number that's more like 8 or 9%. in terms of whole jobs where the entire activities associated with that occupation get automated. But there's also something else that's interesting, which is that there are many occupations, and that's roughly indicated by what's boxed here, where the punchline is something like 60% of occupations have something like 30% of the activities in those occupations that are automatable. So what does that actually mean? What that actually means is that in addition to worrying about jobs that may or may not go away, which is, by our estimate on current technologies, about 5-ish% for now anyway, there's a bigger question, which is people are going to be working with machines a lot more. So that if part of my occupation has a big chunk of what I do that's automated, and we're going to have more and more occupations look like that, we're going to have to think through how do people work with machines, and how do we enable that and make that easy. But that also raises a whole bunch of questions I think Laura may even touch on that may or may not have wage and income implications. We know that when people work with machines in highly skilled environments where the machine is doing the complicated part and the human is still also doing the complicated part, that's actually a win-win by and large. But if you have it the other way, where the machine is doing the hard part and the human is doing what's left over, and there's a large labor supply for those activities, and the skills are not very high, that can put pressure on wages. So the question of what happens when people work with machines is a very interesting one, and we're probably going to see more of that than, at least in the near term, that we will see jobs disappearing altogether. We map this back to occupations. There's a fun chart. What it basically says, each of these dots is an occupation, and we're trying to understand, so which occupations have all of their tasks that are easily automated versus which ones have very few. And what's interesting is that you can see there's some occupations, e.g. file clerks, that are high up on the automatable end of the spectrum, whereas gardeners are relatively low, which is interesting. And so the presumption that it's only the low-skilled jobs that will be automated the easiest is not that straightforward. And you can see where CEOs and other people show up. I'll end up with this chart, and this is to say one of the limitations of much of the work that's been done so far, including our own, is that most of us are asking the first question, which is the technical feasibility question. But we think the actual question is when and how much automation will we see depends on a whole bunch of other things. It depends on, so what will these technologies actually cost to deploy? How does that play into the labor market supply-demand dynamics and the quality of the labor? What about the actual benefits that go beyond just simply labor substitutions that come from this? And what is the response of the regulatory and other social acceptance factors? The reason it's important to think about these other things is, by analogy, if you think about electric vehicles, when was it that we demonstrated that electric vehicles were possible? That was more like 45 years ago. So the technical feasibility for electric vehicles, which is this question, we established that maybe like 45 years ago. But it's taken a whole bunch of these kinds of considerations for them to actually show up on the street, which is roughly about now. So we shouldn't get, the point is, in addition to thinking about the technical feasibility question, maybe getting freaked out by that, let's make sure we also think about some of the other considerations if you look at the history of how technology.
You're getting the picture here that there's here at Berkeley, we like to think differently. We like to push back on the conventional wisdoms in every different category. All right, our next speaker is going to be Kostas Spanos. He is a professor in the Department of Electrical Engineering and Computer Science. Here, he's a well-respected researcher in the area of semiconductor manufacturing. He headed the IEEE transactions on this topic, has published over 200 papers and the textbooks in this area. He's a fellow of the IEEE, and most importantly today, he's also the director of Citrus and the Banatao Institute, which we are standing in at the moment. So, Kostas.
Thank you. So what a privilege to be here, and especially with this very distinguished panel. When I was looking at the names and the amazing depth in policy, in technology, in economics, and so on, frankly, I had quite a bit of anxiety of what to add to that. So I would resort to something that I know, which is Greek. So I would like to introduce 3 words, and 2 of them Professor DeLong has already mentioned. But it's simple. It's going to be very quick lessons. There works utopia, that starts with a U.
Oh, thank you.
There is work dystopia, that many of you know, and there's work utopia that starts with EU. The first and the last sound the same. They're homonyms, but they mean different things. The first word means a place or a situation that does not exist, literally. That's what utopia means. The second word, dystopia, means a place that you want to go there. You don't want to go there. A very undesirable place or situation. And the third word, utopia, with an EU, means a good place that could be feasible. Okay? So I think that in the context of this conversation, I would like to think our balance between these three concepts and how to navigate through them, specifically when it comes to what a university can do about the future. Professor DeLong mentioned that there are many powers out there. The university is just one of them, and especially the public university. But let's define these three words now in the context of what we have. Let's take dystopia. Lost jobs, extreme income inequality, singularity that takes over, right? Utopia, starting with the U, the place that does not exist. AI will solve all our problems. Will make everything very nice, will give us plenty of free time to be creative. The income redistribution is not going to be an issue. But then again, who will manage all this change from here to there? Who will make sure that this technology is possible, even if it is? So that's why it is a utopia, a non-existing place. And of course, you have utopia with an EU, the good place that we would like to go to, which says that AI will enhance our capabilities so they can do more, do it better, and with less effort. It will also free us to do the more strategic, creative thinking and that machines cannot and will not do. Okay. So the question is, what can the research university do in order to steer society, to promote societal interest by steering us to this utopian with an EU future? First of all, you have to be a rational cheerleader of technology. And please understand the conflict in there, right? We are engineers. At least I am an engineer. I'm promoting technology. I'm imagining that technology can solve everything. So I'm a cheerleader of that. But I have to be careful. We have to be careful. We don't want to promote a utopian with a U future because it's a distraction, either positive or negative. So you have to be these rational cheerleaders of technological possibilities. And you have to create utopian with an EU, good paradigms, good examples. Because that's what the university can do. We can show what is possible and communicate it convincingly. So how do those look like? You know, you can think of some examples. Take, for example, self-driving cars. And think of the three different possibilities, right? The dystopian future. Driving jobs will be lost. But maybe it's a future that is not very good for the environment because we'll be sending our driverless cars everywhere, you know, spending more fuel. Maybe we'll need more of them. Maybe we'll live further out in the suburbs, be more isolated, and so on, right? Luckily, this is not possible, but there are other outcomes that are much more desirable. For example, could it be that a self-driving car will finally make transportation a service, a commodity? So the machinery itself is going to be used much more efficiently. It's going to be produced and maintained much more efficiently. It's going to create much more free time and free space for us, for our living. Take manufacturing. Many examples there, right? The dystopian future, we're going to lose all the good jobs and the income redistribution is going to be more tilted towards the higher end. But there is a better future. We can eliminate the boring and the dangerous jobs. We can educate the people using technology, create more free time for more meaningful pursuits. As John said, somebody has to design all the things that can be produced automatically. Take education, right? Here is a dystopian future. Will we become cyborgs wearing intelligence-enhancing prosthetics? Is that possible? Is that even desirable, right? Will you send your avatar to college, eliminating all the natural growth that happens there? Okay, that's some people worry about that. Okay, but there are other ways too. I mean, when it comes to, there are the possible outcomes too. When it comes to disseminating knowledge using technology, when it comes to understanding and customizing how different people learn and adapting to that, there are huge possibilities there, and we're experimenting with those. And of course, there are other areas. There is health, there is art, there is science, there is interpersonal skills. So in conclusion, my concern is what the university do. What CITRIS, what Berkeley, what academia in general can do, what powerful examples can we demonstrate, And it is pretty clear this is going to be a multidisciplinary effort. I don't think engineers alone can put these examples together. I don't think that policymakers alone or economists alone will put those together. I think all these disciplines will come together. And I'm so happy to represent CITRIS because that's what CITRIS was invented for, to have this multidisciplinary research, to put these powerful paradigms out there and make a difference, and make sure that the university is more of a do tank rather than a think tank, as we have done in the past. So with that, I gladly accept Professor DeLong's challenge on behalf of Shankar. And I would like to yield my time to the next speaker. Thank you.
I am delighted to introduce a wonderful colleague and now a friend, Laura Tyson, who has done work all of her career in trade and competitiveness that led her to be appointed as the chair of the President's Council of Economic Advisors and also director of the White House National Economic Council. After that, she became the dean here of the Haas School of Business, where she continues as a distinguished professor of the graduate school. She's also on the board of trustees for the Blum Center, and she has helped Berkeley over these years to become a pioneer in what is now a booming field of corporate social responsibility and social entrepreneurship. Please welcome Laura Tyson.
Thank you very much. Thank you. So maybe I can start to motivate what I'm saying by how I got involved in this. I'm actually not a technologist at all. I actually learned from my son and things like that. But a couple of years ago, and actually it was at a McKinsey lunch at the World Economic Forum, there was a discussion of The Second Machine Age, the book The Second Machine Age, which came out at exactly the same time as a book by Thomas Piketty, Capitalism in the 21st Century. And at this conversation, mostly the people in the room were technologists and business optimists, and they said, God, the technology is really moving fast. It's really going to change the labor market. It's really going to make the need for skills better. We're going to need a whole new social contract, and we're going to need it really fast. So I just raised my hand and I said, social contracts don't come about that fast. They don't come about that fast. They often come from revolution. If this is really moving as fast as you think, we're in trouble. We're in trouble. So I come to it from a kind of public policy perspective, but also from an inequality perspective, because I was reading these two books. One, which is, there's just a new book that Brad has been an editor of. The Piketty book was a major phenomenon around the world in terms of talking about what are the basic drivers of wealth and inequality of income. So inequality of wealth, inequality of income, we've seen it dramatically increase in all the advanced industrial countries. Since the end of World War II, the inequality increase has been most dramatic in the United States, but there it's been. That book says virtually nothing about technology, virtually nothing about technology. It has a simple, for you economists in the room, simple production function. There's a kind of capital, one kind, no digital capital, differentiation from physical capital, one kind of labor, no labor complemented by technology or substituted by technology, there's only capital labor. And so I got involved in thinking about, God, this book about income inequality and wealth inequality and this prediction that it's going to continue in the future is missing what may have been a major driver of that inequality. And so I really spent a lot of time working on an essay for the second, the book about Piketty's book, looking at the effects of technology over the past, say, 35 years on income inequality and wealth inequality. And it's not a surprise, I think, to find that the evidence suggests that in the advanced industrial countries, technological change, which it's not a new phenomena that technology is substituting for labor. It's not a new phenomena that technology is particularly substituting for middle skill labor. It's not a new phenomena that some kinds of CEOs and engineers and people with very sophisticated algorithm sense get higher incomes because their skills are complemented by the technology. But so much of the middle is not being complemented by the technology. The technology is substituting for that middle, pushing people into the bottom where things like gardeners or personal security guards or personal servitudes, personal handmaiden. I'm reading the Handmaiden Tale over again, so yes, okay, personal servants. I was at a technology discussion, I think James was there a couple of years ago, when Downton Abbey was really popular. And one of the technologists on the panel was asked what the jobs of the future would be. I kid you not, he said, I envision a world of Downton Abbeys. Okay, very extreme collections of wealth and big amounts of personal servants for everything you want in a day. Think about all the personal services you want from morning to night. Hey, there should be lots of people. A machine can't do it. Maybe a person can do it. So I spent a couple of years sort of looking at this, and I would say that the evidence suggests that technological change, the kind that we have been going through for the past 35 years, and the globalization that it has enabled. Because economists and public policy people talk a lot about, oh, is technology the source of the loss of middle-income jobs, or is it globalization? You couldn't have had the kind of globalization we had without technological advances. You cannot run a sophisticated, complex supply chain around the world without intelligent machines in terms of logistics, intelligent machines in terms of communications, intelligent machines in terms of managing the supply chain. So basically, I sort of say it's technological change plus technology-driven or enabled globalization has been a key variable in growing wealth inequality and growing income inequality. This happens in a variety of ways. I just want to sort of mention the various ways that technology can affect these kinds of inequality. We talked a lot already about it favors certain kinds of skill categories and not other kinds of skill categories. That's clear in James's picture. It increases the return to capital over labor. We heard that from Brad. Who owns this technology? It is embedded in the capital. It's embedded in the equipment. It's embedded in the algorithm. Somebody owns that, and they own the returns to the productivity that is generated by that technology. So the ownership of capital and labor matter. I've already mentioned technology turbocharges globalization. It increases the advantages for superstars, sort of this winner-take-all idea. If you can sell your skills to the whole world, if you can be the labor platform for the whole world, if you can be the Google for the whole world, you are a superstar. You get in first, you get such an advantage, such a network advantage and a sticky advantage, that it's going to be really hard to displace you. That's winner take all. It's also the creation of enormous, what economists call rents. You can think of them as supernormal profits. Profits above the level that would exist in a competitive market situation. And I think we can see several large firms in the technology space, we can name them, that have supernormal profits. They are earning rents. Who is taking those rents home in terms of income? The owners of the capital, the owners of the talent complemented by the technology, okay, and not many others. Unless the firm decides that for reasons of fairness or equity or internal organizational structure, they're going to do some sharing with everybody. But they might instead say, hey, I want to outsource the things that I can outsource to take care of my grounds or take care of my kitchen or take care of the other things. I don't need to really worry to share the profits with them. They're doing something else. So there are a variety of ways in which technological change can affect income inequality and wealth inequality, and that's just a list of them. The work that's been gone on the most about this is the very well-known work on polarization, which has been well documented. By polarization simply mean if you look from essentially 1980 to 2015, the latest data, you can see in the US and all of the other advanced industrial countries a change in the distribution of employment. There's a growth in employment for highly skilled, there's a growth in employment for low skills, and there is erosion of the middle. The middle is declining as a share of total employment. You can also see that, not surprisingly, in wages, median wages flat or declining, depending on the time period. Wages at the top, skilled distribution rising. Wages at the bottom, low skilled, also basically not rising. So the employment looks like a barbell. the wages look like median stagnating, medium to low falling, top rising. Again, not really surprising because you take the view that the technology is creating demand for certain kinds of skills. Those are the skills that are complemented for by the technology. And it's reducing demand, or let's put it this way, it's reducing demand for the kinds of skills for which the machine can be a substitute. Okay. And by the way, if you're thinking about income inequality, the biggest driver of income inequality is the inequality among wages. Because most people, all the way up to the top 1%, earn most of their income through their labor. We live in systems where basically your income depends on your labor. So if the technology makes your labor less remunerative, if 30% of your activities are taken over by a machine, I don't know, are you going to be paid the same amount you used to be paid? I'm not sure that that's the case, okay? We will take you out. We'll take out the 30%. There's less demand for what you do, and therefore I would predict that's going to be downward pressure on your wages. So I do worry about things like that. Now, since this is also about what we can do, first of all, I love the fact that we're talking about a public university in Berkeley because, look, I'm really engaged right now in the issue of local resistance. Local resistance, okay, on every score. And essentially what we're thinking about here is resisting, coming up with structures, organizations, or I'm going to end on policies that can actually say, wait a minute, we're actually worried about what has happened in the past. We think it's going to get worse in the future if we don't do anything about it. One thing we can do is to try to make choices. I mean, Brad talked about, I think, can we encourage more R&D in the development of technologies that amplify as opposed to substitute for labor? That's a really interesting challenge. I think that's a great thing to do. But we really have to say, what can we do to resist? And here I would just say, this goes back to my social contract point. We live in a society, and all of the societies we compare ourselves to are market societies. They're societies in which people's income depends upon the value of their labor. If there is any danger, and I think there is, that technology continues for a large percentage of the workforce to actually reduce the returns to their labor, increase the amount of returns that are actually going to the owners of machines, not the workers with machines, then we've got to think about what to do as a society if we want a different outcome. So a lot of my numbers, all of the numbers that I was talking about, are really pre-tax and transfer numbers. We can actually do better. Some societies are doing better than the US right now with the same technology, okay? They are, first of all, they are doing much better at education. So actually, if you educate more people to get into the jobs that are complemented by the technology, by the way, what you'll do is you'll bring down the wages of those too, because there'll be an increase in the supply of such things. More and more workers with the high skills needed. You're going to bring down that top level a little, but maybe you just get a reduction in inequality without a decline in the top level of wages. Anyway, education is an important part of the solution, but education cannot possibly be enough, because I'll tell you, I sit in meetings all the time where people say, well, the answer to this is lifelong learning for creative occupations. And I say, okay, lifelong learning for creative occupations. Most people around 40 years old have to worry about the income level they're generating for themselves and their family while they're going to do the lifelong learning education. Okay, even if we design what people should know right, and I think there's a lot of debate about what people should know, how do we protect, ensure their income during the time they're moving to these wonderful, creative new jobs? Okay, I think we haven't even begun to think about that. So whenever I get in a conversation about change education, I say, okay, you tell me how we're going to finance not just the education, but the people's income while they're in this continuous education all life until all of a sudden they get to retire. Okay, maybe they don't retire. That's one solution. Taxation, I won't mention. We can talk about it. It's an obvious issue. One of the observations that was made in the Second Industrial Revolution book, and I think it's important, is whatever we do to finance the new social contract, it would be a really big mistake to put more taxes on labor. That's a really dumb thing to do. Maybe we should have carbon taxes. Maybe we should have value-added taxes. Value-added taxes actually turn out to be highly redistributive if they're associated with very generous social welfare policies. We know that from Scandinavia. So essentially, we can find ways to finance what we need to do. We need to worry about how we tax, okay? And then the last thing I will just say here is we need to think about all kinds of transfer policies in the US right now, and I guess I'll end here. So one of the things that people who worry about the futures and say longevity, people moving through numerous jobs, not a single employer, gig economy stuff where you don't have a single employer, you better have around you a healthcare system. You better have that. That has nothing to do with your employment base, because you're going to be in and out of employment all the time, and it may not be that high level in income of employment. So one of the key things that it turns out you need is a health system. So I will stop there and say that I want to work with my colleagues. I think that the optimism here has to be about we've got to identify the problem and we've got to really push for the right policy environment, because who knows whether this technology is going to be good for the individuals in this room. I will accept the notion that we don't know, but I will say that the evidence over the last 35 years is it hasn't been real good for the middle class in the developed economies. Thank you.
Okay, next we have John Zeisman. John is a professor emeritus of our political science department here at Berkeley. He has written extensively on issues related to European and Japanese policy and corporate strategy. He's author of a number of books, including The Highest Stakes, The Economic Foundations of the Next Security System, and Manufacturing Matters, The Myth of the Post-Industrial Economy. John.
Thank you. As we start, I want to say that, in fact, Brad, Ken, Kostas, Shankar, Laura, and I have all started trying to create a little project called Working, Earning, Learning in the Age of the Intelligent Machine, precisely to try and shape and define the choices that are there and try and encourage that investment in labor-intensive, human-intensive activities over the next years. So we look forward to help and participation in all of that. That said, I was going to follow James Manika, but we're, these AI shoebox characterized super intelligent machines that in fact have flexibility. His slides would present a set of very interesting studies that show that you run from immediate catastrophe in which 47% of tasks, which implies jobs, are about to disappear in the next hour and a half, through to studies by McKinsey and studies by the OECD that 9% to 20% of the jobs will disappear or be changed over the next generation. There's a big difference. Okay. My colleague Brad DeLong would in fact point out that in fact there's nothing, if it's 9% to 20%, that 3% growth won't solve in the next few years, that's a basic and ordinary structural change in the economy, albeit a difficult one. Remember, the Luddites were right, they lost. Society may have benefited, but they did not. So the question and the key issue in our discussions is, can we shape the outcomes? Can we, in fact, alter whether or not we end up displacing work, displacing skills? An important part of that, and we can only begin into that at this point, is that much of what appears to be routine is, as Brad and Ken Goldberg have already said, is not routine. Much of it really depends on human insight, skills, the sensor systems that we, in fact, represent. So I want to make three other points. The first point is really that there's a whole array of things we really don't know. One is we really don't know how many jobs are going to get destroyed because we don't know how the technologies are going to be deployed. They will be deployed in different kinds of ways. The second is we really don't know how many jobs or their character of the jobs that are going to be created. My favorite instance of all this, or in the basement here, is a whole bunch of 3D printers. And a lot of that technology started to emerge. If 3D printing suddenly allowed you to make we moved into a Star Trek world. Ken has allowed us to fantasize. So, I mean, into a Star Trek world, and you can make anything you want. Suddenly, you know, maybe you don't have as many assembly line producers, but you have a lot of designers. Somebody has to decide exactly what they want to make and what they want to sell. And I look at friends of my 25-year-old daughter who are, in fact, into this 3D printing, and they tend to come in pairs. Somebody who does 3D printing and somebody who, in fact, is a designer, an artist trying to find their way into a business. That's a whole set of jobs that are really just not, that are dependent on the technologies and not at all displaced by it. In the same way, the third piece we don't know about, if we don't know what's destroyed, we don't know what's created, we certainly don't know how work is reorganized. Because we will see huge reorganization of activities, and much of that will depend on user interfaces. User interface, funny word, right? I mean, my favorite user interface for this instance is Microsoft Word, okay? We all used to be there were secretarial pools, and they were mostly women. And suddenly we had Word come along, and you suddenly had word processing, and we all became typists, and the whole function that was involved changed. And you ended up breaking the gender line in some of that and changing the organization of it. Similarly, if we look at how technologies are deployed and reorganized, in the automobile industry, you look at what happened with Toyota versus General Motors. Toyota, in fact, had a very flexible system that led to lean production. General Motors went a different direction and got whacked in a very fundamental way. The Toyota system is much more dependent on on worker skills and capacities. And in fact, in that same era, NC Machine Tools, the US had a dominant position. NC Machine Tools that got crushed from two sides. From one side by the Japanese, where very simple kinds of machine tools were used in groups that depended on workers, and at the very high end by the Germans, both of which depended on different kinds of worker skills. So we don't know what kind of work will get reorganized or how the jobs will be given the nature of routine. We just don't know. And that leads to the reality that, in fact, we probably have choices. Because one thing that technology history really suggests to us is that the way technology emerges and the way it's deployed, the way it's developed, really depends on the context. German, Japanese, Northern Italy, Southern Italian, Southern Germany rather, the place and ways in which it's actually developed. So that given that that's the case, given that we in fact are mobile sensor systems, mobile supercomputer systems, how this stuff is in fact deployed will in fact depend very heavily on the choices that we make. So the challenge really becomes, how do we organize ourselves to try and create a world in which these technologies, in fact, augment human capacity, that they become tools in our future rather than machines that overwhelm us. And with that, I think we now have the slides that I was referencing. So I will cede way to James.
The person with the slides.
Excellent. Thank you.
Yeah,
Thank you, John.
The slides.
I was depending on